Let's begin our exploration with the first element in our cycle of look, listen, learn, connect, predict, correct. Looking is about finding stuff. For example, finding stuff on the web, finding stuff on one's computer, or even finding stuff when one looks around a room, when one looks at some data to find patterns which may be hidden in that data, or even finding stuff when one tries to recall things from one's memory. So finding stuff is really essential to what we consider intelligent behavior. But on the web, finding stuff is about finding documents. Let's see how that happens. When we want to look for documents on the web, we type in queries into a search box. And somehow, miraculously, those documents which best match our query turn up. The technique that makes this possible is called text indexing. And let's illustrate that with an example. Let's suppose we have three documents at three different websites, A.com, B.com, and C.com. In our case, these documents are very simple. And let's consider a situation where we have only three documents. And when we type a query into a search box such as Fox, we'd like the first document to be returned. On the other hand, when we type in the bird, we'd like all three documents to be returned because the word the is present in two of the documents and the word bird is present in another two of the documents. Combined, the combination the bird is present in one of these three documents. But when we type the query bird, we'd like only two of these documents to be returned because bird exists in only two documents. To make this possible, what the web does, or what a search engine does, is create what is called an inverted index. So against every possible word which might occur in any possible document on the web, a text index stores which documents that particular word is found in. So for example, the word bird is found in the documents B.com and C.com, whereas the word fox is found only in A.com. So when we type in the query fox, we get one result, which is A.com. On the other hand, when we type in the query the bird, we get two documents, A.com and C.com, from the, and we get two more documents, B.com and C.com, from bird. Taking the union of these two lists that we get back, we get the results which are all three documents. However, if we type in a query bird alone, then we only get two documents, B.com and C.com. A very simple idea, but is fundamental to how the web works. Now let's see what it takes to find a document in such a text index. The web consists of documents which have millions of words. So the number of words on the left-hand side of such a text index is huge. And when we want to search for a word, we have to look up some structure where all these words are stored. So assuming some sorted structure, such as a binary tree, which you may have studied in your data structures courses, is used to store all these words, then looking up a word takes log m time. In fact, you can do a little bit better if we use hash tables, but we won't go into that in detail right now. But it's not enough to just look up the words in your query. We also have to assemble the results that we get when we look up these words. For example, if you have q terms in your query, like the bird, 2 terms in this case, you have to look up the word the and get a.com and c.com, look up the word bird, getting b.com and c.com, and you have to assemble the results, which consists of all 3 documents, and also order them so that the document c.com comes first, because it matches both the words in your query, unlike a.com or b.com where only one word matches. The process of assembling the results of a q-term query takes order rq time if r is the total number of intermediate results. That is, the number before one takes the union of the results. So in this case of a query like the bird, r would be 4 because you get 2 results from bird and 2 results from the. Even though c.com is repeated, you count it twice because you have to traverse both this list as well as this list. To show that this is the case is something I'll leave to you as homework, and we'll come back to this as a homework question later on. The problem is, if R is huge, you really don't want to assemble the entire result set, and you want some other way of ordering the results of a query apart from just which query matches best. And that's the second major invention on the web, and we'll come to that shortly. But before we do this, we'll first look at how the text index is created in the first place. This is something search engines do all the time, continuously, and forms the heart of what's going on inside a large search engine like Google.